This is a short summary of everything I thought I knew about the event loop was wrong. Node Conference Argentina. Firstly, it goes on to sort of say how in the traditional model of a lot of threads, Node doesn't do that. It has one thread and everything operates in one thread, whatever the request is, and it uses libuv as the event loop. And the common misconceptions are that everything that's asynchronous is handled by a thread pool. The event loop runs in a separate thread to the user code, and the event loop is something like a stack or a queue. And essentially we have a main thread here, and as he says, it casts a spell, it gets put onto the stack, the thread pool operates it and resolves it and then returns it to the main thread, and that is wrong. And this is styled by the talk from Bert Belder, who works on libuv, who writes the code for the event loop, and he was looking for images for the talk, went to Google, found lots of really great pictures, but he said they were all wrong. So he was inspired to give this talk. So in reality, there is only one thread that executes JavaScript code, and this is the thread where the event loop is running. libuv creates a pool with 4 threads by default in Node.js, and it's only used for certain types. If you see one of my previous videos, you'll see that's included, where there's no asynchronous APIs available. So things like set timeout, set interval, HTTP requests, they can all be handled by browser APIs. And there is it's not a stack or queue, there's a set of phases or dedicated structures for each phase. And in a sense, this goes back to this picture here. We have an event loop, and each of these are the phases. So what we have is phases for timers, callbacks, polling, set immediate and close events, which we'll have a look at in a minute. And here they are kind of in that loop. And when there are none left, Node exits. So essentially an example of a set timer is set timeout or set interval. Callbacks are things like the request handler for create server. IO polling is reading files. Set immediate is a function that's called, but it's after all of these. And close events is when everything is closed in that loop. So going back, it goes through set timeout, network disk and child processes, anything set immediate, keeps going round. If there's nothing left in the sort of stack, then basically it closes all the events. And here is a tick, and a tick takes place not at the end of every loop, but after each phase. Next tick, and we'll see some code to demonstrate this. So this is really how Node.js event works. And if we come now into some code, we're going to have a look at it. I'm just requiring in some fs utils, etc. We use process.standardout, not console log, because console log is itself an asynchronous event, and if you're doing performance timings, it would affect your performance timing, so it's better to use process standard out. Sync code at the very beginning. We invoke the next tick, nt1. We do some polling to read a file. We do some more polling to go to a website. We then come on down to number 3, where we do a set immediate, and we invoke that function. Then we do a set timeout with 0 seconds. And then we also do an asynchronous function that's in userland and basically does a Fibonacci series, which we call for 20. Then we do another next tick at the end, which is nt2. So what would you expect to see? We have sync, nt1, polling 1, polling 2, set immediate 3, set timeout 4, async 5, next tick at the very end, nd2. So if we come in and run it, what do we see? Synchronous, next tick 1, next tick 2, the async userland function, and obviously depending on the timing of the number of Fibonacci's, it will do another one which runs longer. So we do set timeout, set immediate, thread pool, it's returning back undefined from a file, then it's doing the system polling. So if we come back down here, and we'll change our Fibonacci to something a little bit bigger, say like 30. Open this up, clear, and run it again. You can see there how it took some time. We get the same sort of results, async here. Let's move this up to 35. See, it's pausing, going through the Fibonacci. It's waiting for Fibonacci. That's taking priority. Then it goes through set timeout, set intermediate, thread pool polling, undefined system polling. And I think when he did his, he got his, which was 5, 4, 3, 2, 1. But obviously some things depend on different things with polling and reading files, etc. They're the asynchronous nature. So really, to recap, what we can see is this event loop, and we have a previous video that goes through here. That this is the event loop. It goes through set timeout, set intervals, any child disk processes, then set immediate and close events. And with each of these, we'll see later that will do its own phases. And in between after this, that's when next tick is called. So coming back here, we can see next tick 1, next tick 2 gets invoked, not at the very end of the file, where it is, down here, but simply when we've done the first tick, we do this function, then it comes out, does its process not next ticks, then works through all of these. Because as it goes through each of the phases, because it would have gone to the timeout, the last one, and then worked its way through. So if you want to, you can watch that video and then you can actually see it for yourself. And they'll have a link to the previous video, which actually goes a little bit more into this circle here. So that's it. 6.5 minutes.